Hello, this is part two of the slide. I think I got cut off while talking about dinoflagellates. Dinoflagellates are from the family of protists. They are the ones, shh, okay, one sec. Dinoflagellates are from the family of protists, and when you have when you have eutrophication in the marine layers, you're going to have increased growth of dinoflagellates, usually red tide. I think a couple of months back we had that. We had a bunch of dinoflagellates in the Milford Walnut Beach. It's again the same things. It kind of cuts off oxygen to the layers of water underneath and for life forms underneath. Plus, it's really toxic. Anytime you see the water kind of reddish purple, don't let your dogs in it. Inorganic pollutants, these usually, we've all heard at some point of time the scare about this is where we're going to talk. Okay, let me read. We've all heard about heavy metal deposits. Think about the most important thing here is to think about bioaccumulation when it comes to these things. Accumulation, that takes a long time. Think about bioaccumulation. We've all heard about the scares of mercury and tuna. And this is, again, a major problem because they tend to cause a lot of developmental disorders in kids. So if you guys remember our conversations about Flint, Michigan, when you write an essay about metals contaminating waterways, a very good example would be to use Flint, Michigan here. Mining, especially when they do something called strip mining, this is a big problem. It's called strip mining. Basically what strip mining is that that a mining company buys rights to a certain place. They come in, they dig up these huge trenches. They do what they are there for. They basically strip the land of whatever mining sources, whatever they're mining for, whether it's nickel, it's copper, it's aluminum, whatever they're doing. And then since they are short term, they basically once they're done with taking out whatever they need to, they move on. So, and they actually produce a lot of waste because the process of mining, it's not as simple as you don't dig under the ground and just take out lumps and hunks of iron. You don't dig under the ground and you take out a piece of copper. You take these things in their raw form. They have to be processed. It's a very water intense industry, meaning they tend to use a lot of water. And when they use a lot of water, there has to be some kind of drainage. There has to, and even if they had the best drain systems and even if they had the best ways of cleaning this water before they put it out there, leaching is always a problem. They do produce very high quantities of nitrogen-based contaminants and sulfur-based contaminants. They also produce a lot of acid-based contaminants, so they tend to water bodies that are contaminated by mining byproducts usually are oligotrophic. And then you have obviously all non-metallic salts. Things like a non-metallic salt is just an ionic salt that completely dissolves in water. So if you had something like a huge deposits of calcium carbonate, that would be a non-metallic salt. Arsenic sulfates are non-metallic salts. Please remember these two parts: leaching of road salts, the amount of calcium carbonate that you spray on the road, that eventually, especially in places like Connecticut, once there's a huge snowstorm, put a whole bunch of calcium carbonate, calcium chloride onto the road. I mean, you guys buy the salt too. You spray it out. It increases the temperature. The ice melts quickly, lowers the melting point. Lowers the melting point, the freezing point of water. Um, that seems so stupid for me not to remember that. It lowers the freezing point of water, which is really good, so you don't slip, you don't hurt yourself, all of that stuff. But where does that salt go? It basically leaches into your local water bodies. Arsenic was a huge problem in northeastern Asia, India, and western Bangladesh. As bad as calcium carbonate in your water source is, it's nothing compared to arsenic. We have talked about almost all of this. It's just in the previous chapters we've talked about acids and how acids can cause contamination, how they actually hurt animal life. The acidification of this is just a definition. Acidification really kills off all the life forms there. This is just another other way. Acidification leads to oligotrophy. And we've talked about NOx, which is nitric acid and sulfuric acid, which comes from your mining industry, your oil extraction industry. Every time I say NOx and SOx, that's what I mean. NOx is that nitric acid based stuff, and SOx. Both of these come from burning fossil fuels. So any kind of industry that you set out, industry is very important for human survival. We need all the products that we need. There's no way we're going back to living horse and buggy style and burning whale blubber. So that's just not going to happen. These are just the acids, the sulfurs, the nitrates, the arsenics, the cyanides, the mercuries, the cadmiums, the seleniums. All of these things are byproducts of human living. It is the cost of us living. Couple of other things we'll have to pay attention to here is POPs and VOCs. POPs is persistent organic pollutants. They stay in the system for a really long time. Pesticides are a part of that. Synthetic organic chemicals like BPA are a part of that. You also have different pharmaceuticals where they don't really break down that easily. They are a part of POPs. And then you have volatile organic compounds. Volatile organic compounds are usually something like sulfuric acid, which quickly evaporates, gets into the atmosphere, and then you have acid rain. It can also be any kind of organic compounds, methane gas that's like dissolved in water. You could have octanes and butane and methane, and ethanes. A lot of these volatile organic compounds are also a part of this. One of the biggest reasons for water contamination is improper disposal of industrial and household waste. These are the two basic reasons why water gets contaminated. Most industries are not actively trying to pollute your water sources. What usually happens, one or two things happen. One, it's cheaper, so they don't go through all the steps of purifying the water before they put it out. For example, where we are, the building that we are in, they have, if you look out of the window, you see these huge giant plants that actually purify water. They clean up the water because we are in a chemical company. They clean up the water before they put it into the sewage system. So industries would not clean the water up, not because they're evil corporations or anything. One, because it's cheaper not to. Two, there could be actually a disaster that happens, and by mistake they would have let out a bunch of contaminated water. So both these things require, again, if you want to make sure that that doesn't happen, you need to invest money. You need to have the EPA come in and actually set up some rules. There has to be proper inspection of all these reservoirs where they hold this water. There has to be some kind of legal implications to people who don't follow that. We don't have any of them. We have a ton of laws, but laws with no money is impotent, and laws with no legal recourse to them are just have no teeth. And household waste products, again, most of us have a single stream where there's a collection unit and all our waste goes out. But then there are other places that have well water or have a septic tank system. If you have a septic tank system and your septic tank leaks, now you are contaminating the aquifer at that point of time. The more difficult sources of contamination to control is the second part. The first part is actually easy for us to control with proper legislature and proper just proper mechanism to move the water around, and in terms of households, proper ways to move the water around, proper housing laws, all of those things are controlled. The second part of it is actually very, very difficult for us to control. Kind of gives you an idea as to what the organic contaminants are. Again, I'm not going to expect you to memorize any of these things. This is interesting. How much steroids are in our detection frequency in the samples. There is a ton of human activity that obviously, when you have runoff, this runoff doesn't mean that it's just water. Sometimes it's the soil. Most of the time it's soil that goes along with it. So there's suspended solids in the water. They get into the water system. They also so they basically will sediment at the bottom of the lake. They increase the base of the lake, so your lake is getting less deeper over a period of time. And then there is actually actual cost involved in this. Besides, now most of us, unless it's smothering fish that we like, then that is a cost involved by this sediment moving. The bigger cost involved is that it blocks shipping channels. It clogs your hydroelectric turbines. It also clogs in the water pipelines that bring water into the farmlands. But at the same time, if we had a method of making sure that we dig up the lake and take out all of this sediment, we are getting free soil. So there's that. There is thermal pollution, which is basically we heat up the water and dump it in there. Water is used in electric plants. Water is used in your household where think about you taking a shower. You take a shower in hot water. That hot water goes into your drain pipe and then goes from there. We use hot water for everything. And then there's hotter water than what we take that comes from industrial discharge. That water is also hot. When you take that hot water and you dump it into a river or into a lake, wherever your discharge is, without reducing the temperature, you are reducing the amount of oxygen available. The amount of dissolved oxygen decreases as temperature increases. Molecules start moving faster, so the gas molecule leaves the system. A very good example for this is what happened in the Everglades in Florida, where the electric company was actually dumping extremely hot water into the wetlands. So one of the things they did was, I think it was Rick Scott. I think it was Rick. No, it wasn't Rick Scott. My bad. Charlie Crist. Charlie Crist, who was the governor at that point of time, actually did a buyback of the wetlands and then made it mandatory that the water that the sugar production plants and the electric plants were dumping should actually circulate through their buildings at least one time before it goes into the into the wetland. So by circulating across the building, what happens is that hot water loses its heat to the building itself, and it's also heating the building at the same time. So there's a huge economic incentive for companies to do that. Besides, there was a legal